1 point cracks the code. You've learned 1 point. We started at 0, made 1 simple point, but that introduced a law that each set of parallel lines that recedes goes to a point. But what if 2 sets of lines go away? What if we step off the railroad track? What do we see if 1 set of lines goes away to the right and 1 to the left? Each set would have its own vanishing point. And sometimes, when we're looking up at a thing or down at a thing, the lines going up or the lines going down also recede. That's 3 sets of lines going away from our face. This is based on the 3 sets of right-angled lines on a box. And where those lines meet exactly is a problem we'll solve soon. Now we are learning that 3 sets of lines and their points exist. And, this is important, aware that not everything in the world lines up. 1 of many points. It's easy to label a picture as 1, 2, or 3-point perspective if everything lines up just right, but what if it doesn't? Is this picture in 1-point perspective? Is this in 2-point? What about pictures with multiple points? Let's start with a simple aligned world. Whether we're outside or in. This world has width, height, and depth. Every object in this world has width, height, and depth. 3 dimensions, which we'll label as letters, X, Y, and Z. And they may be, here's the big deal, in different positions compared to each other and compared to the room. This explains so much. You wouldn't believe how many times students have been confused about this. How can it be 2 points and 1 point in the same picture? Well, there's the answer. An environment may be in one view, and objects within it another. Here's what they all have in common. 3 dimensions, which could put any one of them into 1, 2, or 3-point perspective. Therefore, to draw them in 3-dimensional perspective, we study each of their 3 dimensions out of perspective. Hence, this lesson. 3 dimensions, 6 views. Let's name the dimensions again. Width, that's left-right. Height, that's up-down. Depth, that's front-back. Width, depth, and height, the 3 axes of the beloved 3-dimensional world in which we live. Now, back to orthos. The front view shows width and height, but in an ortho, we don't lift our eye up above to see a top plane or below to see a bottom plane. We look straight at depth. The side view shows height and depth. We're looking directly at width. Look how nicely they line up in orthos. The top view shows width and depth. We're looking directly at height. It lines up with the front view. We assume the back and front look alike, unless they don't, and that each side mirrors the other, assuming, and that the top and bottom are the same, unless they aren't. So we may need 6 views for some objects. But an object like this probably only needs 3 views to show how it's shaped from all angles, which means that an architect has enough information to build it in 3D, or an artist has enough information to draw it in 1, 2, or 3-point views. If we did not know teapots and we only had a side view, we might guess it's shaped like this. And if we only had a top view, how would we know it's not shaped like this? But with a side and top view, we have enough information in this case to estimate an oblique view when we learn how. Soon. Of course, a front view would help, just as the side view makes a sagittal section. the front view could make a coronal section. I'll teach you that later, but this is to show you that we use ortho knowledge to draw in perspective. This is why character designers draw turnarounds to build characters to animate. It allows a character designer to decide on proportions and lay them out clearly. It's a basic drawing skill to draw around a character. Let's review with the monster. This front view shows width and height. Who knows how deep? The top view knows. This top view shows depth and width. Who knows how tall? The front view. The same thing goes on between the front and side, but with another mystery axis. The front view shows width and height. Who knows how deep? The side view knows. The side view, like the top view, knows how deep, but does not know how wide, which the other two views do. Now, if you're a beginner and the relationship between these three views seems like a lot to learn, it's all you need to learn for now, and you'll be glad you did when we move on. If it seems too easy, good for you that some of these steps come quickly, but I assure you this can keep you busy whether drawing orthos of several objects or taking the time to guess one view from another and compare your guess to a solution. This is work on three-dimensional thinking, spatial awareness, and spatial reasoning, which prepares an artist to make 1, 2, and 3-point choices. Get this first. If you need help, in Premium we have more instruction. My demos, Phil Demetriadis' marvelous melted pancakes technique to set up our lessons about the horizon, Peter Hahn's skillful drawing of an animal skull as mechanical form. That's at proko.com/perspective. In Premium, we will provide ortho views turned into puzzles. Or if you're the creative type, you can make up your own. But you may want to start with these examples that have been thought through, because when you're inventing from scratch, the comparisons can become a tangle of lines. But let's review the laws. Every front and top view will line up on the widths. Every front and side view will line up on the heights. Ortho law. Remember why this came about. This simplifies going from paper to space, drawings to objects. But we're going to work in the opposite direction, space to paper. Let's do a project to get the idea. A project in no-point perspective. Back to the object you chose for your form study. Draw it from top, side, and front, proportioned as truly as you can. It helps to not be too close. Put it away from your face. You may want to do a little pre-planning for how it will best fit on the page, keeping in mind our principle that if a top view swivels 90 degrees to show its front, it will all line up. The widths won't change. And if the front view swivels 90 degrees to the side, the height lines will stay the same. Now we have orthos. They will force us to notice proportion. This will help us to eyeball our 3/4 views, and it will make drawing in 2- and 3-point perspective more logical and figure-outable. You can use instruments or try it freehand. I recommend both for reasons I mentioned in Premium. Instruments get the lines precise on your paper. That's product. Freehand gets the idea deep in your brain, if you do it a lot. That's process. Getting that ability to imagine in 3 dimensions. If you're feeling enlightened and that this makes sense from just watching it, remember that it takes time and doing it to heighten awareness of space-to-paper relationships, paper-to-space solutions. Space to paper, paper to space, that's what perspective's all about. And with our Zolly app, you get models we made for this. Choose any object, make it go ortho by dragging the Zolly scale all the way down, observe and envision, reveal and revel. That's at proko.com/Zolly. Next episode, we learn about tipping these axes in space from ortho to 3D preparing to sketch any object in freehand. See you next lesson. Freehand.